Hi everyone. So we're back for day 2 of the 4.1 notes on graphs of systems of linear equations. So let's recap what we learned in the previous video. We learned how to look at a graph and write the system of equations. Remember, a system of equations is the same as writing an equation for just one line, except this time we have two, so that's why it's called a system. We learned how to write them in slope-intercept form, and to identify the solution, which is the point where the two lines intersect. Then we also learned remembered how to convert slope-intercept form into standard form, and how you could write a system of equations. You can see it here in green in the middle of the page, how to write that system in standard form instead of just slope-intercept form. And last but not least, we also recapped in the last lesson that there are different types of solutions. So the very first one, we have parallel lines that never intersect, therefore there is no solution. Most of the time we'll have one solution, one point where they intersect, and we would write it as an ordered pair. In this case, this particular problem had one solution at -2, 1. And then last but not least, when we have a line on top of another line, they are always intersecting or always touching. Therefore, there's an infinite number of solutions. So today, we are actually going to graph lines ourselves, where we are given the equations, and we are going to graph them and identify the solution. So we actually know how to do a lot of these things already. Our learning target today is I can graph a system of linear equations. So graphing, yay, and identifying the solution, okay? So what do we already know? We already know how to find slope and y-intercepts from the equations, like where is the m in the equation and where is the b. Can we plot y-intercepts? Yes, remember we plot the y-intercepts and they need to be plotted on the y-axis. We can also plot more points using the slope, rise over run. Now, the only thing that's different is that we're graphing the two lines together on the same graph and identifying where they intersect, which is called our solution. So let's go ahead and look at it. We're going to graph them in two different colors to make it a little bit easier for ourselves to see the difference, okay? We're going to start with the first one, graph f of x. Notice they're named two different things. One's graph f and one is g, so that we can see the difference between the two. All right, so always start with your y-intercept. I usually circle it, and I'm going to plot it on the y-axis. Okay. Then I look at my slope. Now my slope is -1 over 3. Remember, negative means we go down 1, and we always go right. Always start out going right. So I'm going to start at my y-intercept at 1, and I'm going to go down 1, right 3, and put a point. I'm going to do it again. One more time. Now remember, you can also work backwards. So go back to that y-intercept. Instead of going down and to the right, go up 1 and left 3. So see, we can create more points going to the left, because remember, lines go on forever in both directions. And now we can connect them and draw arrows to show that it goes on forever. And I'm going to name it. This is graph f of x. Okay. Notice that it is decreasing from left to right because its slope is negative. Now let's go ahead and look at the second graph, g of x. Our y-intercept is -6. Remember, I circle it so I know where I'm starting. And remember, we always start on the y-axis. So I'm going down to -6. Right here. So our slope is 2. And remember, when we are having a whole number, we put 1 underneath it. So we are rising 2, running 1. And remember, positive means up, and we always go to the right. So I'm going up 2 units, right 1. Up 2, right 1. And keep going. And notice we have a point that is on both lines there. I don't need to keep going because I can already see where they intersect at. And they intersect right on the x-axis. The x-intercept for those graphs is the same. So let's go ahead and write our solution. Our solution is that point where they meet. I'm even going to write the word solution on here so that I know that this is the solution. I'm going to write it a little bit more clearly so that you can see it a little bit better. Solution. You may want to highlight it or something like that, maybe even use a different color if you would like. Okay, so let's go ahead and write the ordered pair of that solution. The solution is 3, 0. Remember, the 3 does have to go first because the x-coordinate of a point always goes first. Okay, so you need to be able to do two things: graph the two lines, and then be able to write the ordered pair of the point that is the solution to that graph. Okay, so take a moment to tape your notes into your journal, your interactive notebook, okay, and then start working on the practice, which is in Delta Math. Thanks, guys. Have a good day.